Good morning, students. In the last video, I explained briefly the concepts of the lesson principles of inheritance and variation. In this video, let me take up some multiple choice questions from the same lesson. It is important to have the material with you while watching this video. Okay, let us take the first question. Which one from those given below is the period of Mendel's hybridization experiments? The correct option is A, 1856 to 1863. Mendel from the 19th century did experiments on pea plants for a long period of 7 years, that is from 1856 to 1863. So the correct option is A. Let us move on to the next question. Among the following characters, which one was not considered by Mendel in his experiments on pea? The correct option is B, trichomes, glandular or non-glandular. As you know, Mendel studied 7 main characters in pea plants. Among the 7 characters, stem height, color of flower, position of flower, color of seed, shape of seed, color of pod, shape of pod. So here, trichomes, glandular or non-glandular, this character was not considered by Mendel. Let's move on to the next question. Third question. The genotypes of a husband and wife are Ia, Ib and Ia small I. Among the blood types of their children, how many different genotypes and phenotypes are possible? Look here. This is the genotype of the husband, Ia, Ib. This is the genotype of the wife, Ia, small I. What is the question? We have to find the possible genotypes and phenotypes of their children. How to find the genotypes? Mentally we can do Ia, one genotype, Ia small I, second genotype, Ia, third genotype, Ib small I, fourth genotype. So 4 types of genotypes. What about the number of phenotypes? A blood group, again A blood group, AB blood group and B blood group. So the correct option is option C, 4 types of genotypes and 3 types of phenotypes. Genotypes 4, phenotypes 3. Which are the phenotypes? A blood group, AB blood group and B blood group. So these are the 3 types of phenotypes. What about the genotypes? Only 4. Let us move on to the next question. Thalassemia and sickle cell anemia are caused due to a problem in globin molecule synthesis. Select the correct statement. Sickle cell anemia and thalassemia both are recessive gene disorders. Both are recessive autosomal gene disorders. But the difference, in sickle cell anemia, there is qualitative problem of hemoglobin synthesis, while in thalassemia there is quantitative problem of hemoglobin synthesis. So the correct option is C. Thalassemia is due to less synthesis of globin molecules. So in thalassemia patients, the hemoglobin produced is less. It is a quantitative problem. While in sickle cell anemia, the hemoglobin produced is defective. It is a qualitative problem. Be clear, thalassemia is, in thalassemia there is quantitative problem of hemoglobin. While in sickle cell anemia, there is qualitative problem of hemoglobin. So the correct answer in here is option C. Thalassemia is due to less synthesis of globin molecules. Okay, let us continue. Let us take the next question, question number 5. A disease caused by an autosomal primary non-disjunction is. The correct option is A. Down's syndrome. Down syndrome is a chromosomal disorder. This disorder is due to non-separation of the 21st autosomal pair. As a result, in Down syndrome patient, one autosome is more, that is 45 autosomes plus X5 or 45 autosomes plus XX. One autosome is more. Which autosome is more? The autosome of the 21st pair. It is due to non-disjunction. Non-disjunction means non-separation. So the 21st autosomal pair is not separated at the time of oogenesis. As a result, instead of 44 autosomes, one autosome is extra, one autosome is more. So the chromosome complement of Down syndrome 45A plus XX or 45A plus X5. Okay, so the correct answer is A. Down's syndrome. The correct option for the fifth question is A. Down's syndrome. Okay, let us move on to the next question. Question number 6. Which of the following most appropriately describes hemophilia? So the correct option is A. X-linked recessive gene disorder. So hemophilia is a gene disorder. It is X chromosome linked recessive gene disorder. See, there is an option recessive gene disorder, option D. It is not the most correct answer. The most correct answer is X-linked recessive gene disorder, that is option A. What is missing in the option D? It is correct but not the most correct. The most correct answer is option A. It is X chromosome linked recessive gene disorder. So the correct answer for the question number 6 is option A. X-linked recessive gene disorder. Okay, let us move on to the next question, question number 7. A big question, a lengthy question. What is tested in that question? Polyploidy. What is polyploidy? Polyploidy is the phenomenon of presence of more than 2 sets of chromosomes in a cell. It is observed in plants. What is the reason for polyploidy? Failure of cytokinesis after karyokinesis at the time of cell division. As a result, suppose if the cell is a diploid cell, if there is no cytokinesis after karyokinesis, the cell becomes a tetraploid. It becomes 4n. So, polyploidy is a phenomenon seen in plants. It is due to the absence of cytokinesis after karyokinesis. So, in this phenomenon, the chromosome, there is more number of sets of chromosomes. So, the correct answer is polyploidy. So, the answer for the 7th question is A. Polyploidy. Let us move to the next question. Okay. 8th question. 8th question is a match the following type question. In your competitive exam, some questions will be match the following type question. In match the following type question, what is the trick to be followed? You should be sure of at least one matching 100%. Then you have to select the options where that matching is found, and you have to delete the other options. So in this case, look at the first one, A. Dominance. It is 100% matches with 2. That is, in a heterozygous organism, only one allele expresses itself. So A matches with 2. So among the options, option A and option D, in those 2 options we can find A matching with 2. So the answer is either option A or option D. So you can ignore the options B and C. Now, let us go further. Codominance. Codominance is in a heterozygous organism, both alleles express themselves fully. So, codominance is matching with 3. Next, option C, pleiotrophy. Pleiotrophy is a single gene influences many characters. So, what is pleiotrophy? A single gene influencing many characters. Okay. Then option D, polygenic inheritance. That is correctly matching with 1. That is many genes govern a single character. So, the correct option here is option A. The correct option is option A for the question 8. Okay. So, that is how you have to tackle the multiple choice questions in the examination. Some questions will be multiple choice question. Okay, at least one matching you should be sure of 100%. Okay, let us move on to the next question. That is question number 9. In a test cross involving F1 dihybrid flies, more parental type offspring were produced than the recombinant type offspring. This indicates. Okay, so the correct option is B. The two genes are linked and present on the same chromosome. Okay, so if two genes are present on the same chromosome, the two genes are called linked genes. The characters corresponding to the linked genes are transferred from parents to offsprings. They don't show any changes. So, what is given here? More parental type offsprings are produced. That means the parental characters are observed in the offsprings. That means the genes corresponding to those parental characters are linked genes. The two genes are linked and present on the same chromosome. So the correct answer is option B for the question number 9. Okay. Next question. Question number 10. Pick out the correct statements. There are 4 statements are given, and those are the 4 options. Let us examine the statements one by one. The first statement: hemophilia is a sex-linked recessive disease. Correct. Down syndrome is due to aneuploidy. So, any chromosomal Down syndrome is a chromosomal disorder. All chromosomal disorders are due to aneuploidy. So, the second statement is also correct statement. Third statement: female catenuria is an autosomal recessive gene disorder. Yes, it is also a correct statement. Female catenuria is a gene disorder and it is an autosomal recessive gene disorder. Let us go through the fourth statement. Sickle cell anemia is an X-linked recessive gene disorder. It is a wrong statement. Sickle cell anemia is a recessive gene disorder but not X-linked recessive gene disorder. Sickle cell anemia is autosomal recessive gene disorder. It is not a X chromosome linked gene disorder. So the wrong statement, the incorrect statement is the last statement, statement number 4. So among the options, the correct option is option C. 1, 2 and 3 are correct. So that is the correct option, option C. The statements 1, 2 and 3 are correct. So the correct option is option C for the question 10. Let us continue. 11th question. A tall true breeding garden pea plant is crossed with a dwarf true breeding garden pea plant. When the F1 plants were self, the resulting genotypes were in the ratio of. So, in this question, a monohybrid concept is tested. You know the monohybrid cross experiment of Mendel. Homozygous tall crossed with homozygous dwarf. In F1 generation we got tall heterozygous, and in F2 generation we got the ratio 1:2:1, the genital ratio 1:2:1. In that 1:2:1, 1 is homozygous tall, 2 is heterozygous tall and 1 is homozygous dwarf. So the correct answer is option D, 1 is to 2 is to 1. Tall homozygous, tall heterozygous, dwarf. Look at in the same question, look at the option A. It is also 1 is to 2 is to 1, but that is not the correct answer, because what is given there? 1 is given as tall heterozygous, wrong. One plant obtained is tall homozygous and another plant obtained is dwarf homozygous, while the remaining two plants obtained tall heterozygous. So the correct option is option D, 1 is to 2 is to 1, tall homozygous, tall heterozygous, dwarf. Right. Let us move to the 12th question. If a colorblind man marries a woman who is homozygous for normal color vision, the probability of their son being colorblind is, okay, look at the board. So the man is colorblind, the woman is normal. Then what is the question? What is the probability of their son being colorblind? So with respect to color blindness, that color blindness character is not directly transferred from father to son. So in this case, the probability of their son being colorblind is 0%, because father cannot directly transfer the character called color blindness to his son. As a result, their son is not having any color blindness. So the correct option is A, 0. Let's move to the 13th question. A true breeding plant is, the correct option C, near homozygous and produces offspring of its own kind. So a true breeding plant is homozygous plant. It may be homozygous for a dominant character, or it may be homozygous for a recessive character. So it is not that it should be homozygous only for a dominant character. You look at the parents of F1 generation, you look at the parents of the P1 generation of monoid class. One parent homozygous tall, another parent homozygous dwarf. Both are true breeding plants. So it is not that a true breeding plant should be homozygous for dominant character. It can be homozygous for recessive character also. So the correct option is near homozygous and produces offspring of its own kind. Okay. The true breeding plant can be homozygous dominant, or it can be homozygous recessive. Okay, let's move to the next question. Question number 14. The mechanism that causes a gene to move from one linkage group to another is called. The correct option is C, translocation. So in a cell there are different linkage groups. There is a possibility of a gene shifting from one linkage group to another linkage group, and that phenomenon is called translocation. So the correct option is C, translocation. For the question 14, the correct option is C, translocation. Right. Okay. Let us move to the 15th question. A gene showing codominance has, the correct option is option D, both alleles independently expressed in the heterozygote. So what is codominance? If the two alleles are dissimilar, both the dissimilar alleles are expressed. So blood group AB is a best example for codominance. Look here, I to the power of A, I to the power of B, heterozygous condition, because both the alleles are dissimilar, and here both the alleles are expressed. So capital I to the power of A, it is because of this allele antigen A is produced. Capital I to the power of B, this allele corresponds to the antigen B. The antigen B is also produced. So if the genotype is capital I to the power of A and capital I to the power of B, both antigens are produced. So that is codominance. Both alleles are expressed. So the correct answer is Option D, both alleles independently expressed in the heterozygote. So that is a gene showing codominance. And let us move on to the 16th question. The term linkage was coined by a direct knowledge-based question. The answer is option A, T.H. Morgan. So the term linkage was coined by T.H. Morgan. Correct option A, T.H. Morgan. Okay. So what is linkage? The physical association of genes on a chromosome is called linkage, discovered by T.H. Morgan. T.H. Morgan did experiments on fruit flies, diabetic cross experiments, and he didn't get the normal diabetic cross ratio. And on further investigation, he found that two genes may be present on the same chromosome, and that phenomenon is called linkage, and that is a deviation from the normal Mendelian principle of inheritance. So here the law of independent assortment fails, and the linkage was, the credit of the discovery of linkage goes to T.H. Morgan when he did experiments on the fruit flies, the Drosophila. Okay, let's move to the next question. That is question number 18. Question number 18. A colorblind man marries a woman with normal sight who has no history of colorblindness in a family. What is the probability of their grandson being colorblind? Okay, look at this. So a colorblind man marries a woman. The woman is normal. The man is colorblind. So they represent the first generation. So what we get in the second generation? The second generation we get the males normal while the females carrier. Then in the third generation, out of 50% of males, 25% of males will be affected. They will be colorblind, while the remaining 25% of males will be normal. So that means color blindness follows crisscross inheritance. Male cannot directly transfer the character to his son. First, the character is passed to the third generation. So the character is passed to the third generation. So in this case, you look at the word grandson, third generation. So in the third generation, 25% of males are affected by the colorblind. So the correct answer here is question number 18. Question number 18, the correct answer is 0.25. That is option D. You can make out option D, 0.25. That means 1 by 4 or 25%. Okay. Next question. In his classic experiments on pea plants, Mendel did not use, this question, a similar question has come earlier. So you should be very clear with the characters studied by Mendel on pea plants. So he studied 7 main characters of pea plants. So pod length character was not used by Mendel. Pod means fruit. So with respect to pod, the two main characters Mendel studied, length, the color of pod and shape of pod, and not the length of pod. Okay, so the correct answer is, for question 19, the correct answer is option B, pod length. Okay, let's move to the next question. 20th question. A pleiotropic gene. Okay, 20th question. A pleiotropic gene. That means pleiotropy. What is pleiotropy? A single gene influencing many characters is called pleiotropy. Its opposite is polygenic inheritance. What is polygenic inheritance? In polygenic inheritance, many genes influence the same character. For example, abiobril. Its opposite is pleiotropy. In pleiotropy, a single gene controls many characters. So there is a sharp difference between pleiotropy and polygenic inheritance. Both are opposite. In pleiotropy, one gene controls many characters. Example, phenylketonuria. What is polygenic inheritance? In polygenic inheritance, there are many genes, but all the genes are controlling the same character. For example, ABO blood group. So here, the answer obviously is for the 20th question, option D, controls multiple traits in an individual. That is pleiotropic gene. A pleiotropic gene controls many characters in an individual, many traits in an individual. So the correct option is D, controls multiple traits in an individual. Let us move to the next question, 21st question. A man whose father was colorblind marries a woman who had a colorblind mother and normal father. What percentage of male children of this couple will be colorblind? Okay, so what is given in the question? Father colorblind and woman who had a colorblind mother, okay, and normal father. That means man colorblind, woman is carrier. Woman is carrier. A woman whose father was colorblind marries a woman. A man whose father was colorblind marries a woman who had a colorblind mother and normal father. What percentage of male children of this couple will be colorblind? That means the mother, here the father normal, mother carrier. So in that case, as I told already, among the males, 50% of males will be colorblind. Among the males, among 50% of males, 25% will be colorblind, other 25% will be normal. So the correct answer is option A, 25%. Okay. Next question number 22. A human female with Turner syndrome. A direct question. You know, Turner syndrome is a chromosomal disorder. It is due to aneuploidy. What is the chromosome complement of Turner syndrome? 44 A plus XO. Total number of chromosomes 45. So the correct option for 22nd question, A has 45 chromosomes with XO. Okay. Let us move on to the 24th question. Which of the following statements is not true of two genes that show 50% recombination frequency? Okay. Again, the concept tested here is linkage. What is the linkage? Physical association of genes on a chromosome. If the genes are linked, the characters corresponding to the linked genes do not undergo recombination. They are observed in the offspring also. And you know, linkage discovered by T.H. Morgan. And there are two types of linked genes: closely linked genes and distantly linked genes. So, what is the question here? The genes are showing 50% recombination frequency. That means, since the genes are showing a recombination frequency of about 50%, what we have to understand, the genes are not linked. If the genes are linked, they don't show recombination. The same characters are observed in the offspring. But here, what is given? The genes are showing 50% recombination frequency. That means the genes are the wrong statement is the genes are tightly linked. The genes are not tightly linked. The genes are not tightly linked. So the option B is not true. The genes are tightly linked. That is wrong. Actually, the genes are not tightly linked. Since the genes are not tightly linked, there is 50% recombination frequency. What is given in the question, we have to select the statement which is not true. That means which is incorrect. So the correct option is B. The genes are tightly linked. Okay, let's move to the next question. Question number 25. A lengthy question, and they again what concept is tested? Codominance. What is codominance? If the two alleles are dissimilar and if both the alleles are expressed, then that phenomenon is called codominance. A best example for codominance is blood group AB, where a person with blood group AB produces both antigens, antigen A and antigen B, because of the expression of both the alleles, that is capital I to the power of A and capital I to the power of B. So the correct answer for the 25th question is A, codominance. This is an example of codominance. Correct option is A, codominance. Okay. Next question. 26th question. If both parents are carriers for thalassemia, which is an autosomal recessive disorder, what are the chances of pregnancy resulting in an affected child? Okay, so what is given in the question? Both the parents are carriers for thalassemia. So what is thalassemia? Thalassemia is autosomal recessive gene disorder, and both the parents are carriers for the thalassemia disease. And in that case, what is the chance of the child getting from that disorder? That is 25%. That is 25%. Okay, let's move to the next question. So the correct answer for the 26th question is option C, 25%. Okay, next question, 27th question. Which Mendelian idea is depicted by a cross in which the F1 generation resembles both the parents? Again, what is tested here? The concept called codominance. So, if the F1 generation shows the characters of both the parents, that means both the alleles are expressed, then that is absolute % codominance. You go through the monometers, tall crossed with dwarf, and in the F1 generation what we got? Only tall character. Only one of the characters of the parents expressed. But here what is asked here? Characters of both the parents are expressed in F1 generation. That means it is an example for codominance. So the answer for the 27th question is codominance, where in codominance only the F1 generation is resembling both the parents. Okay, let's move on to the next question, 28th question. The incorrect statement with regard to hemophilia is. So the incorrect statement we have to identify. The correct answer is it is the correct option for question 28. That is C. It is a dominant disease. So that is the incorrect statement. So what is asked in question number 28? We have to select the incorrect statement. So the incorrect statement is option C. It is a dominant disease. Hemophilia is not a dominant disease. Hemophilia is X chromosome linked recessive gene disorder. I repeat, hemophilia is not a dominant disorder. It is a recessive disorder, and that too X chromosome linked recessive gene disorder. Be clear. Let us move on to the next question, 29th question. A normal visioned man whose father was colorblind marries a woman whose father was also colorblind. They have their first child as a daughter. What are the chances that this child would be colorblind? I repeat the question. 29th question. A normal visioned man whose father was colorblind marries a woman whose father was also colorblind. They have their first child as a daughter. What are the chances that this child would be colorblind? Look here. Normal vision man. The man is normal vision. Okay. What about the woman? Woman's father was colorblind. That means the woman will be carrier. So the man normal, woman carrier. In that case, 100% the child, the female child, will not be suffering from color blindness. So the correct option is option B, 0%. The chances of the female child getting color blind is 0%. Let us move on to the 30th question. F2 generation in a Mendelian cross showed that both genotypic and phenotypic ratios are same as 1:2:1. It represents a case of, okay, what is given? You know very well. In incomplete dominance, in F2 generation, the phenotypic ratio as well as genotypic ratio is same. So, the correct option is B, monohybrid cross with incomplete dominance. Only in incomplete dominance, in F2 generation, the genotypic ratio as well as phenotypic ratio is same. So, the correct answer is option D, monohybrid cross with incomplete dominance. So, the incomplete dominance, that cross which we studied when we begin with, it is a monohybrid cross only because a red colored flower is crossed with white colored flower. There is, the two parents are differing in one pair of contrasting traits. So it is a monohybrid cross. And what we got in F1 generation, we got in F1 generation an intermediate character, that is pink color. Then in F2, what we got? The phenotypic ratio as well as genotypic ratio same. So this is monohybrid cross with incomplete dominance. Okay, let us move to the 31st question. Which one of the following conditions correctly describes the manner of determining the sex in the given example? So the correct option is A. XO type of sex chromosomes determine male sex in grasshopper. You recollect sex determination: XO type, XY type, ZW type. XO type we find in insects like grasshoppers, where the female grasshoppers will have 2 X chromosomes, while male grasshoppers will be having only 1 X chromosome, while the other allosome is missing. So the correct option is XO type of sex chromosomes determine male sex in grasshopper. The other options are wrong. So the correct option for 31st question is A. Okay. The last question of today's session. Select the correct statement from the ones given below with respect to dihybrid cross. Select the 32nd question. Select the correct statement from the ones given below with respect to dihybrid cross. So you have to select the correct statement. So the correct statement is option D. Tightly linked genes on the same chromosome show very few recombinations. Already I said, linkage is a phenomenon of physical association of genes on the chromosome discovered by T.H. Morgan. If the genes are tightly linked, they don't show recombination, or they show least degree of recombination. And on the other hand, if the genes are unlinked, or if they are present very far on the same chromosome, they show more degree of recombination. So, tightly linked genes on the same chromosome, they show very few recombination. That means the same characters we find in the proteins. Okay, that's all today. We shall see in the next video. Thank you.